Okay, today we're going to do the second part of 8.1 and we're going to be simplifying. On last week, we were verifying. So we were using all of our identities and our algebra tools, and we were showing that the left side equaled the right side or the right side equaled the left side. And we did that using those strategies and the identities and algebra tools. And we kind of gave you an end goal. Show us how you get to this point. Now, this is going to be a little different. We're just going to say simplify. So you really, what is difficult about these problems is knowing when you are done. And I kind of think about it as I get to a point where there's nothing more that I can do to simplify down. And the more you do of these problems, the better you'll get. So once again, if you look at that reference sheet that's in Google Classroom, we'll be working in the pink box to simplify. So we'll be using these different identities. And we'll once again use these strategies to simplify. So actually it says for verifying, we can use the same ones for simplifying. And so we'll use these strategies. And I'll try to point out which strategies I'm using as I go through these problems. So let's start with example 1. And I've kind of just put over to the right the identities that I'm going to use as a reference and these strategies. So example 1 says simplify cosine x plus sine x squared quantity squared. And as a hint, I said, let's maybe try multiplying the factors together. So that would be number 5 here. Can you multiply factors together? So I'm going to go ahead and I'm going to expand this and multiply them together. So I get cosine x plus sine x times cosine x plus sine x. And now we're going to multiply, combine like terms, and see what we can get out of this. So if I FOIL, so I'm going to just FOIL like I would normally, and I'm going to multiply these together. So I end up with cosine x squared plus cosine x sine x plus cosine x sine x plus sine squared. Clean this up. I get cosine squared x plus 2 cosine x sine x plus sine squared. So at this point, what I want you to notice is that we have a cosine squared and a sine squared. So if I rearrange these and I write the sines, cosine squared and sine squared by each other, I'll be able to use one of the Pythagorean identities. So I'm just going to rewrite this. It's addition, so I can rewrite it. So now I see that sine squared x and cosine squared x, I have this Pythagorean identity, sine squared plus cosine squared equals 1. So I now can substitute in here and put 1 plus 2 cosine x sine x. So now I'm at a point where I want to say, is there anything else that I can do? It really isn't going to help. Everything's written in terms of sine and cosine. There aren't any square terms, so I'm not looking at the Pythagorean identities. There aren't any fractions that I can manipulate. There aren't any greatest common factors, and nothing else I can multiply together. So when I go through all my strategies, nothing more that I can do. So I'm going to leave my answer here. So that is saying that if I have cosine x plus sine x quantity squared, that simplifies down to 1 plus 2 cosine x sine x. So we just used one, or actually we used two strategies there. We multiplied the factors together and we used the Pythagorean identities. For example 2, I wrote down to try the strategy to rewrite in terms of sine and cosine. Think of common denominators. Think about Pythagorean identities. You could rewrite this in terms of sine and cosine. I also noticed that I could rewrite cotangent as 1 over tangent. So that's where I'm going to start. So I'm going to think of rewriting things I'm not really rewriting them in terms of sine and cosine. I am choosing to think of this as tangent theta all over 1 over tangent theta. And I'm going to get 1 over cosine squared. So I'm just going to kind of rewrite. So I'm really using this first strategy of rewriting. I see a few things here. When I multiply this, this is going to give me tangent theta multiplied by the reciprocal. This is going to give me tan over 1. So I end up with a tangent squared there. And the 1 over cosine squared, I can see 1 over cosine squared. 1 over cosine is the same thing as secant. So I'm going to write this as secant squared theta. And why I'm doing that, I kind of thinking ahead. I'm thinking about if I have tangent squared and secant squared, I'm going to be down in the Pythagorean identities. So let me rewrite this as tangent squared theta minus secant squared theta. So I'm thinking to myself, I can think of things in the Pythagorean identities. So I'm going to go and use the second strategy here of looking at the Pythagorean identities. So if I have an identity that says 1 plus tangent squared theta is equal to secant squared theta, I can manipulate these and rewrite these. We did this on the verifying. So if I rewrite this, I can move secant over to the left and move the 1 over to the right, and I get tangent squared theta minus secant squared theta equals -1. So if I look at that, tangent squared theta minus secant squared theta, that's what I have here. So that means that whole thing is equal to -1. So I've now simplified this down. I've simplified this down to -1. And I did that using a variety of the, with 2 of the strategies. I used some algebra skills where I had to clean up the complex fraction, and I rewrote things in, not really in terms of sine and cosine, but changing cotangent to tangent and cosecant squared in terms of secant.